Hello, everybody. Welcome to our coffee and conservation talk today with Wendy. My name is Christina. I'm one of our associate director of programs here, and Wendy's one of our amazing interns. So thank you for joining us today. We'll give it about another minute and then we will start the presentation.
This is the story of sand. And if you don't really think sand has a story, it really does. So these are kind of some of the areas we're going to be looking at and the life cycle of sand. You know, where does this sand come from? How does it get on the beach? Does it stay on the beach? Where does it go? Really just kind of what the origins are. What have humans done by urbanizing this area and our interventions in the whole watershed? And then what are kind of the consequences of that? And then what are some possible solutions? How can we make this situation a little bit better for everyone? I will give you a little brief overview of kind of the history of what has happened with sand in Orange County, and then look at what we can do moving forward. This is a really big topic. It's a very important topic. There are a lot of stakeholders involved. So there's a lot of information. I'm going to kind of go fast. So again, if you have questions, just put them into that chat. So, you know, Earth is just a big collection of overlapping systems. You know, they're happening at all different time scales and all different spatial scales. And they're all kind of intertwined. And so sand is part of some of these systems. You might know some of them if you want to go ahead and write that in. Most people know about the water cycle. You know, you have the evaporation and then that condenses into clouds. We get precipitation, rain or snow. And then that precipitation, once it's on the land, gets back to the water somehow. And that's kind of the area that we're going to be looking at of the water cycle, right? After it's on the land and it returns to the ocean, you know, what happens to it along the way. And then we have the rock cycle, which I think people are a little less familiar with. This happens at huge geological timescales. You know, we're talking hundreds of thousands of years where the rocks change from one type of rock to another. So the part we're focusing on here is, again, where you have precipitation, and then that water is going to interact with the sediments and the rocks that are on land and actually breaks them down into smaller little pieces, and then is going to carry them down. You know, gravity is going to eventually pull them down to the ocean. And so those sediments get carried along and then they get deposited down here in the ocean or on the shore. So this is kind of my overview of sand's journey. It starts in the mountains. Now, our mountains are mostly made of granite, which gives us kind of that, that sand that we know so well. You know, if you go to Florida, they're going to have a totally different sand. It's a lot whiter and really fine. If any of you have been lucky enough to go to Hawaii, you've probably seen that there's black sand beaches there, there's green sand beaches, and it all depends on what kind of rocks you have that are being eroded, because that's what the sand is made out of. So from the mountains, the rivers are going to carry this sediment downhill. Gravity is obviously the cause of that. And then along the way, that riverbed is going to erode from the sides of the riverbed. And then whenever it rains, you have runoff bringing in sediment from the surrounding areas. So all of this area along the river is also being eroded and then carried downstream. Now, once it hits the ocean, that sediment gets deposited. I don't know if anyone knows why, but think about like a flood and what kind of sediment that can carry compared to just a little trickly trickle. When you have fast moving water, it's going to carry larger pieces and a lot more sediment. And then when it slows down, when that hits the ocean, it doesn't have that velocity to carry the sediment, so it drops it there. Then it doesn't all stay right at the mouth of the river. We have something called the longshore current that's going to carry it down the beach and kind of distribute it along all the beaches. In California, our longshore current predominantly runs from north to south. So all that sand is going to be moving in a southern direction as it gets spread along the beaches. And I made it kind of curly here because the longshore current is kind of a combination of the California current and then also the wave action. So it kind of comes up and moves and comes back down. So that's why that arrow looks that way. We also have other sources of erosion. Wave action can do either erosion or deposition. And we'll look at that in the next slide a little bit. And then also we have some top-down erosion that can happen from the cliffs. You have probably seen, you know, as you've walked along the beach, you've probably seen cliffs with piles of sediment at the bottom, or you may have seen people that are trying to kind of prevent their cliffs from falling down with either plastic or, you know, there's many methods they can use to do that. So we do get, during rain events, we do get some sediment coming down from the cliffs. And then also if the waves are hitting the bottom of the cliff, that can erode the base of the cliff, and then you get chunks of the cliff falling down. So two different ways that that can happen. And then within what we call a littoral cell, which I'll talk about later, the sand will exit the system either by just being pulled offshore or by being pulled offshore into one of these. This is what we call a submarine canyon. So it's just an underwater canyon on the edge of the continental shelf. There's a really huge one in Monterey Bay, if you've ever visited there. So the wave action, has anyone ever noticed the difference between a winter beach and a summer beach? They definitely have a distinct difference. In the wintertime, we have a lot heavier waves, right? We have storms. That's when we get our storms in the wintertime. And those waves actually kind of chew away at the sand and drags it back out to the underwater to the continental shelf. And then in calmer waves, which generally happens in the summer, you get that sand pushed back onto the beach because the waves are just kind of pushing on, they're not chomping down. So that's kind of lucky because obviously summertime is when people want to visit the beach. So it's nice that we have a little bit more area for them to enjoy it. So let's go back to this sands journey, and you can see I've included some big dark areas here that signify what we have done in urbanizing this area. So I'm going to turn on the annotate bar here so you can feel free to draw or even write on here what you think some of these things are, and then where you might have seen them in Orange County, because we do have all of these things in Orange County. So go ahead, mark up my slide. Let me know what you think these are, or just where you've seen them. This one's probably the most well-known. And then this one. So, oh my gosh, can I write with the mouse? This is a dam, okay? And as you can see, it just goes right across the river and it's gonna store water. A lot of the dams that we have are there so that we can have drinking water and then also to stop big flooding events. So if you're trapping the water, you're also trapping the sediment. All right, here, this is a channel. So when you channelize a river, it means that you put the concrete all along the edges, sometimes along the bottom, and that just really keeps the river from, you know, overflowing the banks or from eroding the banks. And of course, if it's not eroding the banks, then it's not carrying that sediment down to the beach. This is a breakwater. And we have a couple of those. Anywhere you have a harbor, you're going to have a breakwater. So that's going to prevent wave erosion and obviously protect whatever is in here. Nice. That is a jetty. We have several of those especially in Newport. And then if you go down to San Diego, they have several jetties in Oceanside and down into Carlsbad. This one is probably the hardest one to figure out what it is, but this is actually just concrete, asphalt, development, paving, and we have a lot of that in Orange County. Anywhere where you have streets or parking lots or strip malls or large warehouses or buildings, that prevents any of that sediment from being carried away during rain events and entering entering the stream and entering the life cycle of sand during erosive events. We could also include seawalls here because there are a couple of seawalls in certain locations, and we'll talk about what that does later. So we have done a lot of different things to the landscape, and we'll take a look at how that what happens when we do that. So just some examples of these flood control projects in Orange County. This is the Prado Dam. Anybody who's ever driven out the 91 has seen this. You can see there's quite a bit of water behind it here that it's holding back. And then it releases it. Here you can see this is channelized right here. This is very channelized. We have the sides, the bottom, and even this just little tiny area for the water to run through. And then here's an example of, just a bridge for Metrolink, but they've also had to build a dam here or a barrier. So, the water can come through, but not everything is coming through. So these are just what we've done to our river systems. And if you look at the whole picture here, this is a littoral cell. And a littoral cell, it can be a number of rivers or streams. Can involve multiple watersheds, and it's kind of just an area where the sand is all moving together, right? It would end with a submarine canyon, and then you would have another littoral cell beginning south of there. And you can just see, this is a great overview of the movement, and you can really see following those arrows where sand is trapped, like right here at the dam. Where's my mouse? There we go, right here at the dam. And then another thing to notice is at this breakwater, you have something called a sand spit, and that's where the sand gets dumped. Well, that's great. We want the sand, but we don't want it in the mouth of the harbor. So they will do dredging of the harbor and then put the sand on an adjacent beach. And that's something that happens every year in Newport Harbor. So, we have this system that we've disrupted a little bit, which, possibly we could regulate just using more sand. But then we have this other wild card thrown in here, which is sea level rise. And sea level rise is really difficult to measure. If you try to measure it from the shore, there's all kinds of different factors that come in, like losing sand, and then some coastlines are even subsiding. Louisiana has a really big problem with this because they're pumping so much oil and gas out of the ground. The ground is actually deflating. And so that, of course, makes the sea level rise look higher than it is. Plus, they've dammed up the Mississippi, so they have no sediment coming in. So they got major problems in Louisiana. But the thing is, sea level isn't actually level. Within one ocean, if you look at the Pacific Ocean, you can have a difference of up to 40 centimeters, which is almost half a meter between one area of the Pacific and the other. And that's due to winds and currents and then just uneven heating of certain pockets of the ocean. So the only real way to measure this is with satellites. And so over the past few decades, the satellites have gotten a lot better, and they can be really, really precise about these sea level heights. But predicting the sea level rise is a much more complicated situation. And you can see there's a huge range here. By 2100, is it going to rise 2.5 feet or 7.1 feet? This is a really big difference, but The reason for that is, number one, modeling is difficult with super complex systems like the ocean. And then also, it really depends on what we do. It depends on if we can keep our carbon and methane and greenhouse gas levels stable. And then just also what happens with currents, and you know, it's hard to predict when an ice sheet will fail, because that will, you know, cause a steep rise in sea level. So many different factors, but the gist is, even at the lowest estimates, it's still going to be rising. And what we know about a 2.5-foot rise, that doesn't sound like a lot, but every inch of sea level rise equates to about 100 inches or 2.5 meters in beach loss. Now, that's very dependable. You know, some beaches are like this, some beaches are like this, some beaches are like this. So, you know, this is not going to be for every single beach, but this is just an average. And it's a lot, you know, because you go up a little, but you go across a lot. It's just a simple little triangle. So I just threw a ton of information at you. Let's pause for some questions if you have any. Nope, we're good? Okay, awesome. Well, then let's keep going. You're ready for more. So what are some results that we've seen of this human intervention? How has it affected, especially California? I first became aware of this in the 90s when I was getting my undergrad in Santa Barbara, and we would actually go down to the beach and look at these coastal processes that were happening. And they have been tracking that for 45 years at UCSB, the geology department. And they have some really excellent photos. They have kind of a photo journal of the whole time. So Christina has some links, and I think I forgot the first one. Yes, I did. That were or will be in the chat. So you can check out this stuff on your own. But this photo was taken in 2005, the one with the pink house, and you can see that the sea has just undermined this cliff and totally taken away all this sediment. And the owners have really tried to save this place with the pillars, but eventually it just got too dangerous. And so they actually had to cut this building way back and actually lose some housing, which is not good for UCSB. And you can see in 2007, this blue structure is what this pink structure used to be. And then they actually had to cut kind of a corner off of this structure next door as well, because the cliffs just keep coming back. And there's only so much you can do to prop them up. Also, to the south of us in San Diego, they've had quite a few problems with this. This was a tragedy that happened in 2019. There was a family celebrating a woman overcoming cancer, and 3 women sitting at the base of the cliff were killed when it just collapsed all of a sudden. So it's really a public hazard. This was one of those situations where the waves had undercut the cliff to the extent that it was kind of hanging over. And, you know, there's not really a lot of beach here, so you can't really sit very far away from the cliff at all times. So yeah, it's definitely a hazard. And then here you can see that we have a lot of infrastructure that is impacted by this. These are the train tracks going through Carlsbad, I believe. And you can see that they are right next to where this cliff is falling off. So we have the Amtrak Metrolink rail lines, and then we also have parts of PCH that go really close to the ocean that could be impacted as well. Oops, sorry, clicked too fast. And some of you may remember last summer, well, sorry, 2 summers ago, oh my gosh, where's time go? When Balboa Peninsula flooded right before the 4th of July. This was just a high tide intersecting with the big wave event, and this storm surge just went right over their beach, right over the dunes that have been compromised, and flooded all of these homes and cars. You can imagine how expensive that is to remediate when your home gets flooded with a foot of water. So what are our solutions? Are there any solutions? What can we do about this? The first one that I want to talk about is dam removal. Obviously, if we have huge hydroelectric dams, those are most likely not going to be removed because we need the clean energy and because it's just a huge monetary investment. But over 81 dams right now are slated to be removed in the Cleveland National Forest. So that's up in like Casper's going across the 74 to Lake Elsinore. There's a lot of, littler dams like this. Maybe it's only 30 feet across and 10 feet wide or 10 feet high. But the removal of those dams actually really helps with that sediment coming down the creek. And the main impetus for this is actually this guy right here, the steelhead trout. They're like salmon, they go upriver to spawn. And so those dams were really preventing them from having access to their habitat. And since they have removed these dams, the steelhead trout have come back in force. And so fishermen are really obviously pleased about that. And of course, this is an important resource for indigenous people. They have been fishing for these steelhead trout for centuries. Some high-profile dams have been removed. There's the Elwha Dam, which is one up in Washington. They had a very successful dam removal. That was caused mainly by the concern for salmon. And I have included a few links where you can see time-lapse footage of the removal of the dam and just how the ecosystem comes back and really revives itself really quickly. And then also some rivers have had parts of their channels returned to natural conditions, either by removing the sides or just even removing the bottom of the channel can help provide some sediment for erosion. Bye-bye, salmon. I mean, trout. So these are some of the solutions that have been proposed as, reactive solutions. The one before was kind of working at the other end with freeing up some of the sediment. But of course, that's never going to provide the same amount of sediment as we had before urbanization, because so much of our land is covered by concrete and asphalt. So there's, of course, the do nothing response, and that's going to result in many homes being flooded and destroyed. There is the protect response, which is kind of armoring the shoreline, and it can be either hard or soft armoring. There is accommodate, just change your house so that it's okay with sea level rise. Oops, sorry. And then there is retreat. Now, this looks really easy. Just move your house back. But as we know in Orange County, behind this house are 800 other houses that go all the way to the foothills. So there's really nowhere to move your home to retreat to. And then at the bottom, we have kind of a combination here of retreating and then kind of some ecosystem support or ecosystem development adaptations, which we'll talk about. So let's take a look at each one of these. As I said before, we do have some seawalls somewhere, some places in, all along the California coast. And seawalls can be really beneficial because they will save a certain structure. They can be built into the cliff, just, right here along the base of the cliff. And they require very little space, right? You can put a seawall in pretty much anywhere you have, 2 feet of space. But they are definitely not all good. There are some major issues. The first of which is they can eliminate the sandy beach in front of the seawall. So here you have the beach and the waves are eroding and the water is slowly rising. But as they erode the beach with a seawall there, all of a sudden you have no beach. And now the water is coming right up to that seawall. So obviously we do not want to lose our beaches. Our beaches are a huge income provider for all of Southern California, probably the #1 draw of tourists to our area. So we definitely don't want to get rid of the beaches. The other thing is wherever that seawall ends, the properties on either side of it are going to have increased erosion because it deflects the wave action and moves it to the side. So if you protect one person's property, the people on either side of them are going to be negatively impacted. So that's another big argument against individuals putting in seawalls, which the Coastal Commission doesn't really allow anymore because of these issues. There is the visual impact, they're just ugly. And they require maintenance. It's not going to last forever. And at some point, you're going to have to rebuild the whole thing. And then with the loss of the beaches, there are some social injustice issues here that you have the public, everybody who owns the beach. The state of California and the Coastal Commission have decided that the public owns the beach and we deserve access to it. And so we are losing access to the beach and we are paying for one individual to keep their property. So that's not really fair, right? They get their home, but we lose the entire beach. And that's kind of, this is an issue with a lot of the solutions. Other kinds of hard structures are jetties, groins, and breakwaters. So you probably recognize this picture down at the bottom, if anybody knows where that is. These, when you have a lot of little jetties, that's when we call them groins. And we don't have this a lot of places. Again, Oceanside has more of those groin and jetty, lots of them in a row. This is a very unique situation here. This is up in Venice Beach. It's just a short, straight breakwater that's just blocking the waves from hitting the beach right here. And you can see it just really saves one little area of beach. And then you have more erosion happening on either side there. So jetties, groins, and breakwaters, their positives are that they can accumulate sand. So if you see down here, this is Newport Jetty, and we have some nice sand right there at the edge. It's going to do that because it prevents the longshore drift from carrying that sand further down the beach. Based on its placement, it can reduce wave erosion. So that's, you know, the harbor jetties are preventing the waves from even hitting the shore. So you preserve that sand that's within the harbor. And then you also protect the boats within the harbor. But of course, one person's pro is another person's con. So sand accumulation on one side of the jetty is going to mean that that other side of the jetty is starved for sand. So it's just going to erode faster. And we do have this situation here in Newport. If anybody recognizes what situation that might be, this would be like the wedge, and this would be Big Corona. And Big Corona has been losing sand just because of these jetties. So disturbing the longshore drift is, you know, beneficial for accumulating sand, but it's not good for those sand dwelling creatures. Things like sand crabs and other little clams, they actually ride that longshore current, and that helps them increase their food gathering area. And so if they run into a jetty like this, you know, there's no more sand and there's no more traveling. So that can be harmful to that population, which, you know, a lot of seabirds depend on. It can also change wave patterns and surf breaks. And sometimes it's actually a good change. You know, a lot of surfers like to surf the jetties, but it can also change them for the worse. And then of course, this is just not really that pretty, all this riprap in the middle of the ocean. All right, soft engineering. Many of us have probably seen this happening. There's different kinds. There's just beach nourishment, where you just add sand to the beach. But then also if we're expecting a major storm or a major wave event, a lot of times they'll build these berms right on the edge. And so that's good because it provides protection from the buildings and the infrastructure behind it. But sand nourishment also just increases the recreation area of the beach. So everyone loves that, right? There's more beach area for people to be able to spread out and enjoy themselves and enjoy the ocean. It can reduce cliff erosion by preventing those waves from hitting the base of the cliff. And it's better at preserving the habitat than the hard structures, because you can still have organisms living in the sand, and you can still have birds that are able to access the sand. But there are some considerations that need to be addressed. First of all, it's super expensive. When you think about that volume of sand, where do you get it? How do you transport it? It's just really a big project. And it's very short term because of the sand cycle. These sand replenishment projects can last anywhere from 3 to 10 years, but that's kind of the longest it can last. So depending on how much wave erosion you have, the lifespan is not that long. And then there are a lot of impacts to habitat that need to be considered. First of all, grain size. Many of us probably don't even think about it. We wouldn't even notice a difference. But if you are a burrowing clam, you're adapted to a certain grain size to be able to burrow into the sand. And same with the sand crabs and the bloodworms that live in the sand. So that's a big consideration, because you could kill off all of those organisms, which, obviously that's going to have an impact farther up the food chain. You also need to look for, where is this sand coming from? Is it clean? Is it toxic? If you're taking it out of a harbor where there are heavy metals or there are sewage issues, you don't want to put that on the beach for animals or humans. It's going to be toxic for all life there. And then if you have those sand-dwelling organisms and you dump too much at once, they can't get out and they will actually suffocate under the sand. So you have to make sure that you're doing it in increments that are that the longshore current can handle. And then finally, you have these huge Caterpillar trucks here that are driving over sensitive habitat. There's a lot of birds and the other animals I mentioned before that use this area, that live in it. We have 2 endangered bird species, the California least tern and the western snowy plover, that nest here. And if those drivers aren't careful, they can just drive right over the bird nest. So we have to be cognizant of when those nesting and breeding times are for when we bring the sand in. So there's a lot of considerations to think about, but most of them can be worked around. So that's why the soft engineering really is kind of our most viable solution. And it's been done. Next, there's accommodate, which, this just makes me laugh because we don't see this out here in California. These houses would probably not be earthquake safe. And then also you think about the building materials that we use in California. We have a lot of stucco and a lot of those concrete brick things. You can't put that on stilts. So this just really isn't much of a solution for our area. It's also amazingly expensive. Can you imagine trying to put some of those houses right on the Balboa Peninsula up on stilts? That's just not going to work. And then also, they're already at their height maximum, so they can't really go up anymore. It also creates access issues. If you look at this, how are you going to get to your house? If the sea rises too much, you're going to be boating or kayaking to your front steps, and that's probably not anyone's idea of a lot of fun. Also, it's a short-term solution. It's just, it's not stopping the problem. It's not slowing down the problem. It's just kind of adapting to the problem. So we can kind of forget about this one. Now, living shoreline, this is kind of trending among coastal managers. It's a really lovely solution. Unfortunately, it can't be done anywhere, but everywhere. But the reason it's such a nice solution is it really mimics the natural state of how our beaches were by recreating those dunes. So you can see the coastal dunes here, and they've put up fences that actually helps to trap the sand that's being blown on the beach. And so we don't lose that sand from the beach. It kind of creates these little hillocks or dunes. And then if you plant native species on it, that will keep the sand there. It does a good job protecting from storm surge. As you can see, the height here, well, I don't know if you can really tell that the height is pretty high. So, you know, it's gradually getting higher here, and then you have the big dunes here. So that's going to protect from a pretty significant storm surge. Once it's set up, there's very little maintenance required. You just have to make sure people aren't walking all over them. So here in Cardiff, they've put these little pedestrian paths so people know to walk right here instead of all over the dunes. Because it's such a natural state, it's going to create a lot of habitat for wildlife. So we can have our nesting birds, we can have our little invertebrates living in the sand that are going to feed those birds. And it's pretty, you know, it looks natural. It looks like a beach. It's not a big, giant rocky structure. So it's really a good solution. Now, unfortunately, we can't put it everywhere. First of all, it's a really large, really expensive project. They didn't just throw sand here. Below this, we have riprap, which are those giant rocks that you see like along the train tracks. And then you have cobble on top of that, and then you have sand on top of that, and then they had to have people go out and plant those native species. So it's not just throwing sand on the beach. Also, you need a lot of space for this. You cannot do this on a beach where you only have 10 feet of beach. You really have to have the kind of perfect location for this. And then again, it's not a permanent solution. It's, you know, depending on how high you make those dunes, it can last longer than some other things, but, you know, it's not the silver bullet, unfortunately. There just isn't one. So that leaves us with managed retreat, which is also sometimes called planned retreat. And nobody likes this solution, right? This is not popular, but it may have to happen. It is pretty much inevitable that at some point we will have to move back from the beach. And it can preserve the structures. It's a long-term solution, but the cons are really pretty huge. It is the permanent loss of somebody's property. And as we know, real estate and especially beachfront property is hugely expensive, and there's nowhere really for these people to move. They can't just move back a little bit. You know, there's really not a lot of land available. And that's going to be extremely expensive for the landowners, as well as for the taxpayers, because if we have to move things like roads and railways, you know, that's going to be a really large expense. This is probably the most famous example of managed retreat. This is the Cape Hatteras Lighthouse. You know, they have a lot of trouble on the East Coast because there's a lot of barrier islands and just sand spits where people built stuff, and those are not permanent. So they had to actually move the Cape Hatteras Lighthouse. You can see they had to make this road all the way back there, and then they have, you know, tiny that little truck is. This is a giant structure, and they had to put it on rollers, and, you know, it was a major project, but it's a historical building, so they wanted to salvage it. Here's another example of managed retreat. This is at Fort Ord, which is up near Monterey. This is, I think the Cal State Monterey actually took over most of the Fort Ord buildings to put their campus there. And here was one building here, Stillwell Hall. And it was, you can see that the cliff is just fallen down here. We've got a bunch of sediment at the bottom. And so eventually they just had to take the structure away. You can see here's the parking lot that used to be behind it. Well, now that's cliffside. So, you know, the building would have been half off of the cliff by now. So this was one of those situations where that's really all they could do. So let's quickly go over Orange County's sand history. It mainly all started in the 1940s. When we started building a lot of those erosion structures and channelizing things and putting up dams. And then the Navy built these two huge jetties right outside of Anaheim Bay. So Anaheim Bay is the harbor that serves the U.S. Naval Weapons Station, which is back here in Seal Beach. And so they basically put up those really long jetties, are almost 4,000 feet long, to protect the bay. Now in 1964, there's started being some problems with this lack of sand. And so the Army Corps of Engineers basically did a study and they said, oh, you're right. You know, it was those jetties that, and those flood control structures that are responsible for sand loss. So they said, we will supply sand and we'll do sand replenishment. But then in 1996, they decided to abandon it and not fund the project anymore. So somehow it still got done until 2009, but 2009 was the last sand replenishment. And this is what it looked like. This is Sunset Beach here. And so you can see a lot of sand. These houses are nicely back from the shore, so they're nicely protected. But this is what it looked like by 2018. So they didn't have any sand replenishment, and you can see there's very little beach here. And these houses are really, really close to the water. So in 2022, we are hoping that the Surfside Sunset Project nourishment gets renewed. It's already been passed by the House of Representatives. We're waiting for approval by the Senate, but we're hoping that that comes through because that will be very helpful for a lot of those northern Orange County beaches. Now, some of you might be thinking, wait, I have seen sand replenishment since 2009. And that's probably in Newport Beach because they have their own yearly dose of sand because they're right next to the Santa Ana River mouth. So when they dredge the Santa Ana River mouth, they take that dredge and they put that on Newport Beach. So Newport's lucky, they have their own source of sand. But north of them is not so lucky, and south of them is not so lucky either. But that Surfside Sunset Project is supposed to bring in 1,750,000 cubic yards of sand. That's a lot of sand. I wanted to kind of give you a visual. So if you took a 40-foot standard shipping container, that would be 20,000 of those worth of sand. So it's not going to be dumped all at once, but it is going to cost $15,500,000. And part of it's paid by the U.S. Army Corps of Engineers, and part of it's paid by the cities or the counties. And that sand will be added to the beach immediately down coast of the Anaheim East Bay Jetty, which is the photo I just showed you with the lot of sand and then a little sand. But we still have problems. That's not going to solve all of our problems, especially for these people right here. I actually spoke to a lady yesterday from my Pilates class that lives in one of these homes, and these are in Capo Beach, and Capo Beach is a really small city. And so they don't have a lot of pull, they don't have a lot of money, and they aren't getting replenished. San Clemente is doing their own replenishment, but it's going to be south of these houses. And so these guys are kind of left, I would say high and dry, but they're not. They're low and wet. They're left low and wet, and they're going to get really hit hard by this. So, you know, the problem, it differs in severity between cities. Here is, this is actually right in front of my house, and there used to be a beach here, but there's not anymore unless it's super low tide. And guess what? The train tracks are right there. And even last year further south, the train tracks were washed out and they had to stop the Amtrak and Metrolink service for a couple weeks while they fixed it. So, you know, it's already having an effect on the infrastructure. And this is Laguna Beach. You can see these houses are right there. I don't know if these are probably condos or maybe hotels, but there's not a lot of room here for sea level rise to happen. So what do we do moving forward? You know, like I said, there is no silver bullet. There's no perfect solution. So, you know, it's really going to be like any other good solution. It's going to have to be integrated. We're going to have to use every tool that we have to to help with this, right? We are going to have to do sand replenishment whenever we can and to the extent that we can. We should continue with dam removal and de-channelize some of those river channels to free up a little bit more sediment naturally coming down. Living shorelines are excellent where they can be put in. So anywhere where it's appropriate, we should be supporting the restoration of those living shorelines. And then we're going to have to embrace planned or managed retreat. And, you know, that's not to say that every single person along the coast has to move their house, but the more that we plan for this and accept it, the easier it's going to be, right? Especially with things like the railroad tracks and PCH, you know, things that the government can control. They really, and they actually are. A lot of the reports I read are really looking forward and trying to figure out how we can do planned retreat as painlessly as possible. But unfortunately, it's not, you know, it's not great news. So hopefully we can do everything in our power other than that while we figure that solution out. So I loved researching this. It was so interesting. I went down 1,000 rabbit holes and got totally, you know, wrapped up in one topic or the other, but it was super interesting. So these are some of the links that I believe Christina put in the chat. If you're interested in any of them, you know, if you're wondering what sea level rise, how did they figure that out? Is this real? This is the NASA kind of short explanation of that. Anyway, if you feel like exploring, these are some good places to start. These are many of the resources that I used. And there's a lot. Oh, whoops, I didn't need to click on one. Whoops. Well, thank you guys again for joining me, you know, on a beautiful Saturday. I really appreciate your attention.
And this will also, this is recorded. It'll be posted on our website. So if there's anything you want to play back later and go back to, this will be available shortly that you can check out on our website too.
Okay, thank you.